Right, this video is meant to be for the virtual students, but also for anybody looking for a little more review for the test. The test for Unit 1 is going to be on the topics you see here. Pythagorean theorem and distance formula, which we did on the quiz, and then of course all the transformations that we have done since, okay, translation, reflection, and rotation, as well as putting those together. And then, of course, we worked with parallel and perpendicular lines. You are expected to know how to work with those, how to find equations of lines, things like that. And you should also know the basic things that we've done with quadratics so far. So factoring, finding intercepts and graphing, finding the vertex, okay, things of that nature. What we're going to focus on in this video is the transformations. So we will go over one more time how to translate something, how to do a rotation by 90 or 180, how to reflect something over the axes or the lines y equals x and negative x. We'll also talk about putting those things together. And when you're on the test, you can just state the new coordinates. You don't have to draw a picture, although that is helpful for many of you. So if you want to use graph paper or anything like that, you certainly can. But you can see, a test question is just going to ask you to state the coordinates of the new point. So you don't have to draw pictures unless you find that useful. All right, so we'll start with translations. Those are the easiest, of course. To translate something simply means to move it across the page. And we can use a rule you've probably seen like this. Okay, but more often you're going to see it as a vector. Please use brackets, right? Not parentheses. Parentheses are for ordered pairs, right? So we don't want to be confusing when I say this. That has a very specific meaning in math. That means, a point, -5, 3. Okay, when I use these brackets, or some books will use these brackets, I don't care which you use, right, that has another meaning, which tells us, okay, this is a vector. We are going to translate by this amount. The x coordinate of an ordered pair now just becomes the x movement, right? What's going to happen to your x coordinates. And so when I write this, okay, it's telling me 5 units to the left, right? Moving the x coordinate 5 units into the negative direction, and then the y coordinate 3 units in the positive direction, right? Moving up. And it's just a matter of really adding. If I take a point and I translate it, so this point B, and I translate it by this vector, to find the coordinates of B prime, I simply add or subtract as needed. So moving to the right by 9 is just going to increase the x-coordinate by 9. So that will become 2. And then moving down by 4, right, is going to decrease the y-coordinate by 2. And again, if this was a quiz or a test, that's all we need to see. No work required. You don't need to explain anything, just simply giving that final answer. Rotations are a little more complicated. Okay, we talked about this in class. The idea of, right, drawing that perpendicular line. So we start at some point C, and we want to rotate it around the origin. Okay, this would be rotating counterclockwise, 90 degrees. Clockwise would be this way. You can abbreviate, that's fine. All right, and we explored, and we did some things in class to see what's going to happen. But now you can simply memorize, okay, the coordinates are going to switch, and then one of the signs will change. And we talked about the reason for that, right, are these opposite reciprocal slopes, right, forming the 90-degree angle. That's why we talked about perpendicular lines, or one reason anyway, right? Instead of moving right and up, now we're moving, left and up. And so that's going to have the opposite slope, and that's why one of our coordinates is going to end up being the opposite as well. Okay, so we can see like 6, 2 becomes 2, 6, but the 2 needs to change to a negative because we're in this quadrant, okay, the second quadrant. So that's the easiest way to figure it out is, okay, which quadrant am I going to be in? And then I just switch my coordinates around and change the sign to accommodate wherever I'm going to end up. Okay, so this would be 90, we'll talk about 270 as well in a moment, but for 180, you just need to remember to change the signs. Okay, and again, we said the slopes, if you want to think of it that way, right, you're going over and up by the same amount that you're going to go backwards and down. So instead of going forward 6, you're going backwards 6. And instead of going up 2, you're going down 2. And so you can see the coordinates are going to be the same, just opposite. xy becomes negative x, negative y. The way to check this, right, instead of making a right angle, now it will make a straight line. So you should be able to connect C and C prime with a straight line, and you can, right, through the origin. And same thing for B. For 270, well, just realize that any 270-degree rotation is just 90 the other way, right? If we do 90 degrees counterclockwise, that is the same thing as 270 clockwise. And so you don't really need to memorize a separate rule or anything for 270. Just think of it as going 90 the other way. That covers rotations. Okay, you may want to try a few examples if you want to pause the video at this point and make sure you can get these answers. And then I will catch up with you. All right, so when I do these, I like to draw a picture. It just helps me. I'm going to start with p, -2, -5, and you don't have to get the graph paper out or do anything or even make it to scale. Just like put it where it's supposed to go. Okay, I know p is going to be in this quadrant when I do that. And let's see, I'm going to go 90 degrees clockwise. So that means when I rotate, I'm going to end up in this quadrant. Right? Each quadrant is 90. So 90, 180, 270, and then 360 would get you back. So if I'm in this quadrant, I know my x-coordinate is negative and my y-coordinate is positive. So I'm going to switch my coordinates. Right? If I just switched them around, I would end up with this. But that's not going to make sense. So then I just need to look, well, where am I? Okay, I'm in this quadrant. That means I need to change this to a positive to make sense. So that's what I do. And that is p prime. Okay, make sure you label your coordinates, please. All right, q. Let me start over again. Okay, again, just draw roughly where it goes. So 4, -3 would be down in this quadrant. I am rotating 270 degrees clockwise, so around the clock. 1, 2, 3 this way. Same thing as going 90 this way. I'm going to be in quadrant 1. Well, that's easy. Both coordinates are positive, so I just simply need to switch them around and make them both positive. And then the last one, okay, 180 degrees clockwise. I'm not even going to draw a picture for this one because I know I simply need to change the signs on the coordinates. Oops, sorry, that should be q prime. All right, if you can get those answers, then you understand how to do a rotation. If not, let me know. All right, we'll talk about reflections now. Reflections are what they sound like, right? Looking for some kind of mirror image across a line of reflection. And most often in a pre-calculus class or a calculus class, we're going to do this over the axes, okay, the x and y axes. And those have simple rules, which is just that one of the coordinates will change, right? So if we look at this example, okay, we're starting with this as our pre-image. And then we're reflecting it in two different ways. Okay, one way is to go over the y-axis. And if you think about it, okay, well, I'm just going to go straight across. So my y-coordinate's not going to change. Right, it's going to stay 7 the whole way. The only thing that's going to change is instead of going 5 this way, I'm now going 5 in this direction. So my x-coordinates are going to switch. Likewise, if I go this way over the x-axis, well, that has the effect of keeping the x-coordinate the same, but changing the y-coordinate. Okay, my 2 becomes -2. You can memorize that if you want. I've had students who say, okay, if it goes over the y, then the x-coordinate's going to flip. I think it's just as easy to draw a picture if you can't remember. Oh yeah, the y-coordinate's going to stay the same. Okay, that works better for me, but however you do that, okay, that is one thing you are responsible for knowing how to do. Okay, you also need to know how to reflect over the lines y equals x and y equals negative x. Y equals x has the effect of just switching the coordinates around. Okay, so we started with this original triangle, and then flipping it around. Okay, 6, 2 becomes 2, 6. 2, 4 becomes 4, 2. Okay, and so on and so forth. So just switch them. Don't change the signs. Don't do anything else. Just flip them around. When you do it over the line y equals negative x, you flip them around and you change the signs. Okay, so 2, 4 becomes negative 4, negative 2. And if you had, just to do another example, if you had negative 4, 2, okay, you're going to flip that around and change the signs. So that will become negative 2, positive 4. And then you can visually confirm, oh yeah, that is a reflection across that line when you do that. Okay, so you flip the coordinates around and you change their signs for that translation, or for that transformation rather. Okay, you may want to try this. Okay, again, if you want to pause the video, make sure you can get these answers, and then I will catch up with you. All right. Reflecting over y equals x, simple as switching them around. P is going to be P prime rather is going to be negative 5, negative 2. Done. Okay, Q is reflected over the x-axis. And again, if you can't remember, okay, if I'm going over the x-axis, that's right, only the y-coordinate's going to be the one that changes. The x-coordinate stays the same. Okay, so that's going to be 4, positive 3. And then the last one, okay, reflecting over the line, y equals negative x, r prime. I'm going to flip them and switch them. So 4 goes over here, becomes negative 4. Negative 7 goes over here, becomes positive 7, and I'm done. That's it. No work required. Drawing pictures is optional. Do whatever you need to do to get these answers. So that is the transformations by themselves. Okay, now we need to know how to put them together to make more complicated transformations. So you might see a test question, something like this. Okay, we give you a point. A is 4, negative 3, and we're going to do a couple things to it. We're going to rotate it 90 degrees counterclockwise around the origin and then translate it and find the coordinates of A double prime, right? So that implies after the two transformations have been done. So we're going to start with A. Okay, we're going to rotate to get A prime. And then we're going to take that and we're going to translate it to get A double prime. Okay, so you want to think of it as taking one point and then doing two things to it in order. And please always go in the order presented in the question, because you could get different results if you do them in a different order. You should try that sometime to see what I mean. All right, but let's start with 4, negative 3. Okay, I'm going to start by rotating it 90 degrees counterclockwise. Again, for me, a picture is really helpful. So I'm going to start down here. 90 degrees counterclockwise is going to go against the clock like this. Okay, they're both positive, so I know A prime is just going to be 3, 4. I'm going to switch the coordinates and change the signs to the appropriate signs for that quadrant. Okay, then I'm going to translate, and I'm going to translate by this vector, so A double prime. I'm going to take 5 away from the x-coordinate. I'm going to add 3 to the y-coordinate, and I win. I'm done. That's it. Please show that intermediate step. Okay, when we're grading these, that would be partial credit. And if you made a mistake here, but you did the translation correctly, let's just say you did A prime was 1, 4 just by mistake, and you wrote A double prime is negative 4, 7, you still did the negative 5, right? So we're still going to give you the point for doing that. So please show those intermediate steps. All right, very good. Last thing is just to go over a couple of special patterns that happen. When you reflect over two lines, it has the effect of translating the shape. Okay, we talked about how you flip it over and then immediately unflip it, right? You bring it back to its original orientation. And what that does is it effectively slides the image across the page. And it turns out that that is always going to be twice the distance between the lines. The only thing you need to decide is which way it goes, and I'll go over that one more time. The other thing is when you reflect over both axes, it has the same effect as simply rotating 180. And you can think about why that is, right? We know 180 means change the sign of both coordinates. Well, when you flip over the y-axis, you change the x-coordinate, and when you flip over the x-axis, you change the y-coordinate. So it does the same thing, just in 2 steps. So one last example of the double reflection thing, okay, would be something like this. You can try it yourself if you want, or I will go through it now. So I'm going to, first of all, again, drawing a picture, helpful for me. I need to do it to see some of these sometimes. So -2, -5, k is down here. So then I'm going to draw my lines. All right, well, y equals 2 would be some horizontal line going through 2, and y equals -4, let's see, would be above my point, all right, because that was at -5. Helps to label, by the way, so you can keep everything straight. So now think about what it's asking you to do. You're going to reflect over y equals 2, and then y equals 4, -4. So I'm going to go up this way, right, to start, because I'm reflecting over this line, and then wherever I end up, I'm going to end up coming back over this line. So you can see I'm going to go up, and then I'm going to go down. So I'm going to translate down by, okay, now it's just a matter of how many units. Well, again, you just find the distance between the 2 lines. So this is a distance of 6, right? 2 to -4, and we double that. 6 times 2 is 12. So we're going to translate down by 12 units. If you wrote that, I'd give you full credit, because it's the right idea, but you could also say translate by 0, -12. Okay, the ultimate answer is P prime is -2, -17. Now, you could get out the graph paper and actually do these 2 reflections if you wanted to. Okay, you would get credit for doing that, but we would ask you, like, what would this be the same as doing in one step or one transformation? And this is what we're looking for. Again, in words, I would also accept that. Right, and then very simply, Q prime, you're going over both axes, you're going to change both coordinates, the sign on both coordinates. Okay, no work required there. And that'll do it. All right, if you have further questions, please let me know. Happy to answer an email, or I can always hop on Teams with you. In the meantime, you can check Canvas. You'll see there's a Unit 1 test review. And what I've done there is I put a few questions. This is not meant to be a big, comprehensive review sheet that does every single thing that might be on the test. Rather, it's meant to be a few questions that try to put a bunch of things together. And if you can do those questions, you're probably feeling pretty good. But you still want to go back through your homework, look at the harder examples especially, right? The things we went over in class are probably good things to look at again. And then what we'll do on Friday is we'll go over the review questions along with anything else that you want to cover on that day, and the test will be assigned as a take-home over the weekend. All right, I hope this was helpful. Again, if you need anything, please just let me know, and have a great day.